Hi everyone, welcome back to our channel. So now we are going to solve the problems on Z parameter. Now the given problem is problem number 3. The following readings are obtained experimentally from an unknown two-port network. That network is not given to us. Compute the Z parameters, or what we need to find out is we need to find out Z11, we need to find out Z12, we need to find out Z21, and we need to find out Z22. So these are the Z parameters what we need to find out. So this is the tabular column given to us. And in this tabular column, it's very clear that I2 is 0, is nothing but output port is open circuited. So current is 0. And in this tabular column, input current is open circuited, that's why I1 is 0. So we have the standard Z parameter equations, or V1 is equal to Z11 I1 plus Z12 I2 is one set of equation, and V2 is equal to Z21 I1 plus Z22 I2. So if you get any confusion of how to write down these equations, just remember V1 V2 is equal to Z11 Z12 Z21 and Z22 scaled with V1 I1 I2. Then automatically you can get it Z11 I1, Z12 I2, Z21 I1, Z22 I2. So this how. So here what is given? I2 is 0. I mean this I2 equation becomes 0. Then we need to compute Z11. Therefore Z11 is equal to V1 by I1. And next what we need to compute is Z21 is equal to V2 by I1. So here V1 is how much when I2 is 0. When I2 is 0, we require V1 and I1. So V1 given is 100 volts and I1 given is 10 amperes. So automatically the impedance offered is 10 ohm. So in this case, when I2 is 0, we need to find out V2. V2 is how much? 60 volts, and I1 is 10 amps. 10 ones are 10 6 are, which is 6 ohms. Similarly, uh, input port is open circuited. Under this case, I1 is 0. So in this equation, substitute I1 is 0 and this I1 is equal to 0. So when you make these two terms as 0, then resultantly you are going to get Z12 is equal to V1 by I2, and next one Z22 is equal to V2 by I2. So substituting those values, what is the V1 value? So V1 is, sorry, what is the V1 value? 30 volts divided by, what is the I2 value? 3 amps. 3 ones are, 3 tens are, which is nothing but 10 ohm. So here V2, what is the V2 value? 40 volts divided by the current is 3 amperes. So 40 by 3, we are going to get it as, okay. So that's how we successfully computed Z11 is how much? 10 ohm. Z12, I mean the reverse transfer impedance is again 10 ohm. Z21 is 6 ohm and 22 is 40 by 3 ohm. That's how we find out those values step by step. So this is how to find the Z parameter. These are the impedance values of the given network. Okay. So the following readings are obtained experimentally of an unknown two-port network. Compute the Z parameters. We successfully computed the Z parameter. So this equation should be there in your brain. Then only the things will be very clear. So V1, V2 is equal to Z11, Z12, Z21 and Z22 scaled with I1, I2. So now directly we can write down this equation should be there in your brain. So how to write down V1? V1 is equal to Z11 I1 plus Z12 I2. Next one, V2 is equal to Z21 I1 plus Z22 I2. This equation, then the brain, you can solve any kind of problem instantaneously. Let us try to solve one more category of problem. So this is problem number 3. Let's try to solve one more problem of this category. So more the problems, if you solve in circuits, you become more professional, more expert. So there's nothing but problem number 4. Draw the equivalent circuit of the Z parameter model. Draw the equivalent circuit of the Z parameter model of the two-port network. So the Z parameter equations are given as follows. The Z parameter equations are V1 is equal to Z1 plus Z3 of I1 plus Z3 into I2 is one equation. Next equation given in the problem is V2 is equal to Z3 I1 plus Z2 plus Z3 into I2. So this is in an standard format. So what is the standard format we have? So when you want to write down in standard format, just remember this equation: V1 V2 equal to Z11, Z12, Z21 and Z22 scaled up with I1, I2. So what are the standard equations? V1 is equal to Z11 I1 plus Z12 I2. So next is V2 is equal to Z21 I1 plus Z22 I2. So now what is this? Z11 is Z1 plus Z3. What is this? Z12 is Z3. What is this? Z3 is Z1. What is the value of Z22 is Z2 plus Z3. Now already we know the equivalent circuit of these two equations. Already we have been solved in the previous sessions. Those are new to the session, you please look in the following. This is the equivalent Z parameter model. So solving the concept here. So here how to draw this equivalent circuit is, we have a voltage source of V1. So we have a voltage source of V1, and within the branch, what is the impedance offered? The impedance we are going to write down it as Z11. What is the applied voltage? V1. This is the drop. The entering current is I1, Z11, and this is an impedance, another impedance. Okay. So here we want to transform into an V1 minus Z11 I1. Next one minus Z12 I2. Like drop my, raise minus drops equal to 0. So similarly here also we have to write down Z2 is equal to V2 minus Z21 I1 minus of Z22 I2 is equal to 0. Just I moved this to left hand side to write down the cables, very simple. So this is one drop, and you can see this drop, this is not linked at input port, this is at output port. So we are going to draw an dependent source with the polarities of positive, negative. The magnitude of this source is Z12 I2. So input port is completed. Now let's try to see the output port. So output port, the applied voltage is V2 and the drop is Z22 I2. So here we are writing the drop. This is Z22 I2 and the drop at input side is Z21. This we have to represent with an dependent source. This is a dependent source, positive, negative. The magnitude, so Z2 to I2 is related with output, but this is related with input. How to write down the input port parameter at output side is this with help of this dependent source. The magnitude of this source is Z21 I1 join input port and output port. Now we are going to get this equation. Now you may get down what kind of source this is. I2 is an dependent and this is a voltage source. This I2 is called current dependent voltage source. These are called current dependent. What kind of source? Positive and negative polarity is there. Voltage source. Both are same. Okay. This is also a current dependent voltage source. So now just replace. What is the value of Z11 we got? Z11 is equal to Z1 plus Z3. What is Z12 value? Z12 value is Z3, that's all. So replace Z3 into I2. And what is the value of Z21? What is the value of Z21? Z21 is Z3 into I1. Just replace this. And how to write down the Z22? Z22 can be written as Z2 plus Z3 into I2. So this is called, we have been successfully drawn the equivalent circuit on the Z parameter model for the equations what they have been given. So this is very simple to understand. We need a lot of practice to make things to understand better. So this is how to solve the problems what they have been given for us in drawing the equivalent circuit. Okay, so this is all about how we find different problems. So in the upcoming class we'll discuss some more few problems, and let's try to solve one more problem which will close with this kind of category of problem. So problem number 5 is draw the Z parameter equivalent circuit. It has been given. Draw the Z parameter equivalent circuit with the values of Z11 is equal to 10 ohm, Z12 is equal to 10 ohm, Z21 is equal to 6 ohm, Z22 is equal to 13.33 ohm. We need to draw it. So same, whatever they given there is also same. So I will repeating the things in a clear fashion to make you to understand. So these are the values given. So now let's try to write down the standard format. What are the standard equations of V1 and V2? So V1 is equal to Z11 I1 plus Z12 I2 is one equation. Second equation is V2 equation. So V2 is equal to Z21 I1 plus Z22 I2. So what are the values of Z11 and Z12 given? So V1 is equal to 10 I1 plus 10, 12 is 10 I2. V2 equal to Z21 is 6 I1, Z22 is 13.33 I2. So these are the two equations what we are having generally. Now for this we need to draw the equivalent circuit. Let's now try to draw directly the equivalent circuit what we are more familiar. Just replace those values. So these equations are very familiar to us. Now for this we'll apply and we'll replace this Z11 as 10 and replace this Z21 as 10 and replace this Z21 as 6 and Z22 as 3.6. So this is the equivalent circuit already we have been drawn. Okay. So now I will make you the things more clear. So this is like a voltage source and all these are voltage drops. Now let's try to redraw the network, the equation. So V1 minus Z11 I1 minus Z12 I2 is equal to 0. So this equation I can write down V2 minus Z21 I1 minus Z22 I2 is equal to 0. So now what we need to do is we need to draw the equivalent circuit. So already I have been drawn here. So those are able to understand this, it's well and good. Those are unable to understand, you can see the procedure here. So input voltage, input impedance, and this is output impedance, but we have to represent in input side. So this I am going to represent with an dependent source. So now how to draw is input voltage is V1 and impedance is Z11 and entering current is I1. The terminals are positive, negative, and Z12 I2 is an output port parameter. So that's I'm going to draw with an dependent source as shown figure. What is the leaving terminal? Minus, this is positive, negative, this is Z12 I2. For this equation also I'm drawing. So this is a voltage source V2, and here you have an impedance corresponding at output side is Z22 I2. This is Z22 and entering current is I2 with the terminals are positive and negative. So output voltage, output impedance map, okay, we had drawn, but we want to show this our input parameters in terms of output parameters. That's why we are going to use an impedance triangle like this, and we are going to connect it. The terminals, what is the leaving terminal? Minus. This is positive, this is negative, this value is Z21 I1. So join this input node and output node. So whenever you see this, this is Z21 I2, this is Z21 I2. What kind of source this is? Positive and negative. So these kind of sources are called current dependent. What kind of source? Positive and negative polarities are there. Voltage source. This is also same. So now you, what are the values given? Z11 is how much? So this Z11 is 10 ohms, and Z12 is how much? 10 into I2, and Z21 is 6 into I1, Z22 is 13.33. So this will be the solution for the question asked. Draw the Z parameter equivalent circuit. This is the required Z parameter equivalent circuit. So for the given equation, if you want to draw, you may get confused. Just draw the fundamental basic equation, which is in the standard format. V1 is equal to Z11 I1 plus Z12 I2, Z21 I1, Z22, and reframe in the understandable form, and just replace those parameters of Z11, Z22, Z12, and Z22. So hope with these problems you are very clear about how to solve multiple problems what we get in different type of problem. This is third problem. So parameters are given, we find the Z parameter. This is how to draw the equivalent circuit. So all solving these multiple problems will help you to solve more problems. So you can see the previous video, we had already solved multiple problems on this the second problem, and this is the first problem. So things will be more clear when you understand or you solve the more problems. So thank you for watching. If you're watching for the first time, if you feel the content is useful, please like the video, share the video with your friends, and if you have any doubts, let me know in comment section. And if you're watching for the first time, please subscribe to the channel. This is a free channel for the betterment of students, which will help you to prepare for multiple competitive exams and different subjects. Viewers, wrong. We'll meet in the next video. Thank you for watching.